Synthetic division is a shortcut we can use when we have some function, some polynomial, being divided by something in the form of x minus a. So when we have an x to the first power minus some constant, we can use synthetic division to cut out a lot of the unnecessary work. You can see here, this is a problem I've solved using long division. I have done 2x cubed minus 5x squared plus 3x minus 14 divided by x minus 3, which is in this form of x minus a. We have an x, a positive x of the first power minus some constant dividing into a polynomial. And I've done all of the work already. You can see that we can do this long division. We can say, well, how do we get x to equal 2x cubed? Well, we multiply it by 2x squared, and then we subtract, and then we multiply that times the divisor. We get 2x cubed minus 6x squared. We divide out. We get 1x squared plus 3x minus 14, and we do the whole process over and over again until we get a remainder of 4. And what I'm about to show you is synthetic division, and it's very easy to use once you understand what it's doing, and it cuts out almost all of this work. You can see that we've done all of this addition and subtraction. It's very easy to make a mistake. But synthetic division, it's not very work intensive. How about that? So let's talk about what's happening in our long division. So again, it must be in the form of x minus a, and when we have something in the form of x minus a, these terms, as you can see, these front terms are always going to cancel each other out. So these 2x cubed, and then 1x squared, 6x and 6x, they're always going to cancel each other out. So we can kind of ignore this, and what we can do is that the only term that's not going to cancel out is the 3. So we can take this 3, and then we can just multiply it by the coefficients. So we can get the 6, and then we can figure that out, and then continue on down. So let me use synthetic division. It'll probably be easier to explain. So in order to do synthetic division, we write out the coefficients. So I have all the coefficients here written out. Write out the coefficients of each power. So for x to the third, and we write them in descending order. I start with x to the third, then here's x squared, here's x to the first, and here is our constant. So I have them all written out, and what I do is I bring down the power, or bring down the coefficient of the first power. I multiply 3 times 2, and then I get 6. Now I add these two, and now I have 1. Then I multiply 3 times 1, and I get 3. I add these together, I get 6. I multiply 3 times 6, I get 18. Now I add these together, and I get 4. And this is the remainder. If there is no remainder, it will be a 0 if it divides out evenly. But if there is a remainder, it will be the last term. And this is the constant. This is x to the first, and this is x squared. And if we had higher powers, I forgot to put this word. If we had higher powers, then the rows would be over to the left. Well, let's see what this means, what we just got by synthetic division. When I divide it out, this is what I got. I got 2x squared plus 1x plus 6. And if we look here, I have the coefficients for them, and I have the remainder of 4, and I have that here. So we see that synthetic division gives us the correct coefficients of our term that we've divided out and the remainder. And we can see when we look through the division now, since these terms cancel out, essentially what we are doing is just multiplying 3 times 2 and then doing some addition. So we get that 1, and we can see we have that 1 here. When we did 3 times 2, we got 6, and minus 5 plus 6 gives us 1. As you can see, that is what happened here. And the reason that this isn't a minus is because the minus side is already included over here because it's in the form of x minus a. So this is how synthetic division works. It basically just cuts out all of this unnecessary addition and subtraction because we already know they're going to cancel out anyways. So it's a very fast way of dividing something in the form of x minus a. And it's confusing for some people. If you really don't like using it, or if you're very confused by it, then just stick with long division. And it's useful to learn eventually, because there are a lot of tests that are where we're looking for factors and checking for zeros, and where there are going to be in the form of x minus a, and it's much simpler or more simple to do or synthetic division than long division. But like I say, if you're not very comfortable with it, I remember when I first learned synthetic division, I wasn't really that comfortable with it right away. So I continued doing long division until I decided that I kind of liked math and I wanted to keep doing it, and then I eventually learned synthetic division at my own convenience. So if it bothers you, it's something I definitely recommend learning, especially if you are going to continue on in math. It's all too often that we're dealing with things in the form of x minus a when we're factoring, when we're doing all kinds of things. And synthetic division is something that's very useful. It will crop up quite often. It's not one of these things that we won't ever see again. We might not use it for a while, but in calculus and differential equations, there are many, many uses for synthetic division. But of course, long division will always work, but as you can see, it's much, much more work. Here we just did 3, we brought down the 2. We did 3 times 2, we got 6. We added these together. We brought the whatever this added to be, we brought that here, then we multiplied, and then we added that over here, added these together, then we multiplied, and then we added these together, and we got the remainder. So that's all there is to synthetic division, and it's much faster, there's less chance for a mistake, and here it's all addition. There can be a minus. So suppose if we had x plus 3 instead, well then this would have been a minus 3 over here. Remember, it's in the form of x plus a. I'll do some more problems just to kind of guide through the steps, because it is not very complicated. It's a little bit confusing when you first look at it, but once you understand the steps and where this comes from, and I really recommend when you first learn synthetic division to put it next to a long division problem. You can see what is happening, where all these numbers are coming from. Essentially, we're just cutting out all of the superfluous information and just dealing with the important numbers at hand.